In this video, we will find out the solution of biquadratic equation with the help of Descartes' method. So let us start with a question. The question is, apply Descartes' method to solve the following biquadratic equation. The biquadratic equation is x to the power 4 minus 8x cube minus 12x square plus 60x plus 63 is equal to 0. Let us take this to be equation number 1. So first here we see that all the terms are present. So the first thing we'll do that we'll remove the second term by using synthetic division. Then we'll get a transformed equation and then we will solve that transformed equation with the help of Descartes' method. So let us proceed. First we'll remove the second term by using synthetic division. For synthetic division we need h. H is minus of a1 by n a naught. A naught is 1, a1 is minus 8. So we'll put the value and the value of h we will get is 2. So as if we are doing the synthetic division, we'll write the value of h in the leftmost corner and the coefficients of the biquadratic equation, that is 1, minus 8, minus 12, 60 and 63. 1 will remain as it is. 1 into 2 is 2 and on adding these two we'll get minus 6. Minus 6 into 2 will be minus of 12. Minus 12 minus 12 minus 24. Minus 24 into 2 will give minus 48. And on adding these two we'll get 12. 12 into 2 is 24 and on adding these two we'll get 87. 1 will remain as it is again. Then 1 into 2 is 2. These two when added will give minus 4. 4 2s are 8. Minus 8. So minus 24 minus 8 will give minus 32. Minus 32 into 2 is minus 64. And on adding these two will get minus of 52. 1 will remain as it is. 1 into 2 is 2. Minus 4 plus 2 is minus 2. Minus 2 into 2 is minus 4 and on adding these two will get minus of 36. Again in the next step 1 will remain as it is. 1 into 2 is 2. Minus 2 plus 2 is 0. So the second part is removed here. So the transformed equation is z to the power 4 minus 36z square minus 52z plus 87 is equal to 0. Let us take it as equation number 2, where z is x minus 2. So the value of x is z plus 2. Let us take it as equation number 3. Thus, we have reduced the given biquadratic equation in the form of equation 2. And now Descartes' solution may be applied here. So let us assume that z to the power 4 minus 36z square minus 52z plus 87 be equal to z square plus pz plus q into z square minus pz plus r. Take it as equation number 4. On multiplying further, we will get z to the power 4 plus r minus p square plus q into z square plus p into r minus q into z plus qr. Equating the coefficients of z square, z and the constant term from both the sides, we will get r minus p square plus q is equal to minus 36, p into r minus q is equal to minus 52 and q into r is equal to 87. So we will take it as equation number 5, 6 and 7. Now this equation 5 implies that r plus q is equal to p square minus 36. Equation number 6 implies r minus q is equal to minus of 52 by p. So here on adding these two and on subtracting these two, we will get the value of 2r and 2q. So 2r is equal to p square minus 36 minus 52 by p, and 2q will be equal to p square minus 36 plus 52 by p. Now multiplying these two, that is 2r and 2q, will give 4qr, and that is equal to p square minus 36 minus 52 by p into p square minus 36 plus 52 by p. Now from equation 7, here the value of qr is 87. So 4qr will be 4 into 87, that is 348. So this will be equal to p square minus 36 whole square minus 52 by p whole square. Now on the right hand side, we'll square it. So we'll get p to the power 4 plus 1296 minus 72p square minus 2704 by p square. On further solving this, we will get p to the power 6 minus 72p to the power 4 plus 948p square minus 2704 is equal to 0. We'll take it as equation number 8, and this is a cubic equation in p square. Now let fp be equal to p to the power 6 minus 72p to the power 4 plus 948p square minus 2704. So we'll put the value of p to be 0. When p is 0, the value of f0 is negative. When p is 1, the value of f1 is again negative. But when p is 2, the value of f2 is giving 0. Hence, one root of this equation, equation number 8, is 2. So we'll put p is equal to 2 in equation number 7. Here, where q into r is equal to 87. qr is 87, 2r is p square minus 36 minus 52 by p. So here in 7 dash, we'll put the value of p. 2r is equal to p square minus 36 minus 52 by p. So on putting the value of p, we will get the value of r to be minus 29. And 2q will be equal to minus 6, which gives the value of q to be minus 3. Now from equation number 4, z to the power 4 minus 36z square minus 52z plus 87 is equal to z square plus pz plus q into z square minus pz plus r. So putting the value of q and r here will give z square plus 2z minus 3 into z square minus 2z minus 29. So if z to the power 4 minus 36z square minus 52z plus 87 is equal to 0, we'll equate these to be equal to 0. So here we have two quadratics. So on equating separately with 0, we'll give z square plus 2z minus 3 is equal to 0. So the value of z on solving this quadratic will give minus 3 and 1. Next, on solving the quadratic z square minus 2z minus 29, the value of z is 2 plus minus under root 4 plus 116 by 2. So on taking 2 common, we'll give 1 plus minus under root 30. Now we have 4 values of z. That is minus 3, 1, 1 plus minus under root 30. But here we have to find out the value of x. And what is x? X is equal to z plus 2 by equation 3. So we'll put the value of z here. X is equal to minus 3 plus 2. It will give the value of x minus 1. 1 plus 2, that is 3. 1 plus root 30 plus 2 is equal to 3 plus root 30. And 1 minus root 30 plus 2 will give 3 minus under root 30. So this is how we have solved the biquadratic equation with the help of Descartes' method. Thank you.